Question 4 says, in the circuit below, all the resistors have the same value. The ammeter reads 1 amp. Put that here. Find the current in the black resistor. So you might be able to jump to the answer straight away, but if we try and explain our reasoning clearly. So in this bottom branch, I'm going to just color these resistors red so we know which ones I'm talking about. In the red resistor, the current in each red resistor is 1 amp all the way along that branch. So it's 1 amp in all three. Therefore, because those three are in series, we can say the total potential difference in the red resistors, or the potential difference in each resistor, must just be equal to its resistance. So for those three red resistors, the V in the reds is equal to 1 times their resistance. So the total on the branch is 3 added together because they're in series. So 3R. So the voltage on there is 3 times the resistance times 1 because the current's 1. Then we've got a parallel part of the circuit. So if we're picturing this loop here, then Kirchhoff's law tells us that the potential difference up in this resistor has to be the same as in the three reds. So let's color this one in purple so we know which one I'm talking about. So the V in the purple resistor has to be equal to the V in the red branch, which we've just said is equal to 3 times R. So this means now we could work out a current that's going through this branch. We have to be a bit careful here because of our notation. So the voltage on this resistor we know is 3R. Its resistance, however, is R. So the current in the purple resistor is equal to V in the purple resistor over its resistance. So that is 3 amps. Now you might have looked at this at the start and said, of course, this ammeter is going to be 3 times bigger because there's 3 resistors to 1. If you did, great, but this is kind of our full reasoning. Then these two currents join back together. So at this point, we must be up to a current of 4 amps. Then looking at this, shortcut, I suppose, is just to say, well, it splits evenly, 2 amps at the top, 2 amps at the bottom. Why does it split evenly? Well, because here we've got 2 resistors in parallel. The potential difference on the 2 resistors has to be the same and their resistances are the same. So of course, the current in them both has to be the same. It has to add up to 4. So the 4 amps splits between the 2 identical paths, giving us 2 amps for our current through the black resistor.